Hello everyone. In this lecture, we will learn about the different type of linked lists. So there are four types of linked list. The first one is single linked list. Then we have doubly linked list. The third one is your circular linked list, and the fourth one is circularly doubly. And let's understand all these linked lists one by one with the help of examples. First of all, we'll understand single linked list. So in single linked list, the node has two parts. So this is your node. The first part contains information. So in information, you can store any kind of data that you want to store. It can be of any data type, whether it is integer, float, character, or it can be a structure, or it can be a record. And so here I have stored the information. Next part contains the address of the next node. So this is the next part which will contain the address of the next node. So if there is some other node available here, it will store the address of that node. Now let's understand it with the help of the example. Now this is the first node and this is the address of the first node, right? Similarly, this is the next node, or because this is the second node as well as this is the last node in this particular example, and this is the address of the last node. Now in this first node, I have stored the information, and then this is the address of this particular node is going to store the address of the next node. So this is the next node and this address is being stored here. Now again in this next node, we are storing the data, and here it will contain null. As we can see that the next of last node will contain null. So here we have only two nodes. So this is the last node, or you can also call it as a second node, and there is no other node where it can point. So that is why it is going to point to null. It means that it is not pointing anywhere, right? And one more thing I want to discuss here is we have a start pointer, and that start pointer is going to store the address this. So it will be pointing to the address of the first node, right? So start, or you can also call it as head. So for in every linked list, there will be a start or head pointer which will be storing the base address of the linked list, and that from that base address, again when we have the first node, that first node will contain the address of the next node, and the next node will contain the address of the next node. In this way, we can traverse to all the nodes, but the head pointer should be known to you. Now let's understand doubly linked list. Now in doubly linked list, it has three parts. So this is your node. The node has three parts. So the first part is information, and the information stores any kind of data that I have already discussed in the previous slide. Then we have next. So this next is going to store the address of the next node, right? And previous is going to store the address of the previous node. So now let's understand this with the help of the example. Now this is your first node. This is the address of the first node. Then we have another node. You can call it as a last node, and it also has some address, right? These addresses are different. And then in the first node, I have inserted the data. I have now this address, because this particular next part will store the address of the next node. So this address, so it is pointing to the address of the next node, right? Now in the next node, we have inserted the data, and its previous part will contain the address of the previous node, that is 1000. You can see that. And because this is the last node, so it will not be pointing to anywhere. So no node is there to point. So that is why it is pointing to null. And the previous of the first node, because there is no node to point here also. So that is why it will contain null. And again, there will be a start pointer or head pointer, which will store the address of the first node, right? So in this way, we can traverse from one node to another node in doubly linked list. Now let's understand circular linked list. So in circular linked list, again it contains two parts. So this is your node. The information part contains the information or data that you want to store, and next part again contains the address of the next node. Now let's understand it. How is it different? Because it is resembling like the linked list in case of the node, but there is a slight difference. So this is the first node. This is the address of the first node. This is the second node. This is, or you can also call it as the last node. And this is the address of the last node. Now the first node will contain the data. First part of the node, first node will contain the data, and this address will be the address of the next node, right? So this next part of the first node is storing the address of the next node. Again, in the next node, we have inserted the data, and here, instead of storing null, because this is circular, so circular means next of the last node will contain the address of the first node, right? So again, as I've told you, start pointer is there or head pointer is there, which will store the address of the first node. What is that? 1000. So it will point to the address of the first node, which is stored in start, right? So it is not going to contain null, but it will contain the address of the first node, that is 1000. So you can see that in this way, it forms a circular chain. Now let's understand circular doubly linked list. So in circular doubly linked list, it has three parts because it is a doubly linked list. So this is your node, right? Information part will again contain some data or element. So this is your information part. Then we have next part, which stores the address of the next node. We have the previous part, which stores the address of the previous node, right? Now let's understand it with the help of the example. So let's take this example where we have only one node. So this is the first node and the only node available in the linked list. This is the address of the node. So in the information part, I have inserted some data. So now what will happen in this next part? Will it be null or will it be storing some data? Because it is circular also. It is doubly as well as circular. So this is going to store the address of the first node itself, right? And the previous is also going to store the address of the first node itself because it is pointing to the node itself. Now let's understand when there will be two nodes. So here, this is the first node. This is the address of the first node. This is the next node, or you can also call it as the last node because there are only two nodes in this particular example. This is the address of the next node, last node. Now again, the information part will contain, I have inserted A here. So here in the next part, what address will be stored? To 2000. Now let's see. This 2000 has been inserted. Now again, I will be inserting some data in this information part of the last node. So data has been inserted. Now, previous part of this node is going to contain the address of the first node. So it will store the address of the previous node, right? And what will be next? It is not going to point to null because this is circular. So it will store the address of the first node, and that is stored in start pointer, right? The start is pointing to the address of the first node. So here the address of the first node that is also stored in S start will be saved. What is that? 1000. So we can say that it is now connected to the first node. And similarly, this is going to store the address of the previous node. And as this is circular, so it will point to the address of the previous node. And what is that previous node? This is your previous node because it is circular in nature. So it will contain what? 2000. That is the address of the last node. So this was all about the different types of linked list. Now in the coming lectures, we will discuss all the linked lists in detail. So the first linked list that we will discuss is single linked list, and in that we will be doing understanding all the insertion operations as well as deletion operations. And there are different cases of insertion and deletion. We will understand with example, algorithm and time complexity as we have studied in case of stack and queue also. Stay tuned to my lectures. Thank you so much.